So now declare. It is configured in process 100. You must have established a relationship with it in process 100. Then this device. You can learn the 1.1.1.1 network segment you are announcing now. But it cannot learn the network segment 2.2.2.2 you announced. Because the processes are isolated. You opened a different process ID. It is equivalent to multiple OSPF. OSPF opens two process IDs. This is two OSPF. The contents of each other are non-overlapping. Later you will learn. There may be many ways to connect devices. Then you will encounter all kinds of problems. You must never open a process on the device 10. Made some builds with it in. Then opened another 20. Made some builds with it in. Opened a 30. Made some builds with it in. Finally, it was found that the entire network was disconnected. It doesn't use much. So just let everyone know. And the process ID is locally valid. Locally valid is if OSPF is running between two devices. The process ID can be different between them. They are also able to establish a normal relationship. This is called locally effective. This is the first parameter. Further down there are other parameters. The next parameter is the router ID. How is it identified? Let's go back to this picture. We just wrote here that the generator of the message. I am in R3 if I make some announcements. Then the device will generate information. A device generates information to tell other devices. So we will fill in the router ID of this device here. Tell other devices that this information was generated by it. So in the information generated by each device will carry its own router ID. The router ID cannot be repeated. For example, now, between R1, R2, and R3, each device generates some link state information. They are not repeatable. It's like our graduation thesis. Everyone can't write the same content. The same is true for routers. Now the exchange is LSA. Then the LSA must indicate who originated it. I give an example. The router ID of R1 is A. The router ID of R3 is also A. R1 is now on the 12.1.1.0 network segment. R3 is on the 23.1.1.0 network segment. That is, now A has generated two messages. R1 belongs to this network segment. R3 also belongs to this network segment. Then please note, it generates this information based on the interface. That is, this interface will be this network segment. It will be this network segment. This is outrageous. There is no way for our information to be synchronized and calculated. Because information can be confusing. So under the same region, the router ID must never be repeated. But in the future you will learn OSPF multi-area. Then under multi-region. That is, under different regions. Sometimes the router ID can be repeated. We just talked about LSDB. I said all equipment will maintain a bucket. This bucket contains information about all devices. We will learn in the future. OSPF is based on area to synchronize LSDB. For example, these devices now belong to a region. Belongs to area 0. Then there are some devices that belong to another zone. Belongs to area 1. Certainly. There will be a device in the middle. So here are the different devices. Suppose the device is called A. In fact, this device can also be called A. Then if the two devices, no other data interaction will be performed. They can. But sometimes there is a problem. When I introduce a root on this device, originally, they would maintain a. In fact, the contents of the calculations do not interfere with each other. The two of them ultimately do not need synchronous routing. How to perform data forwarding in the end. There will be a default route here. After this, you will learn it at the NP stage. But I tell you, there will be problems when this thing is repeated. In this case it can actually be repeated. But if I'm on this device, introduced an external route, it becomes another character. You will learn ASBR later. It is equivalent to an externally introduced router. If it introduces a message, then it will generate a link state message at this time. Identifies that this is generated by device A. Then the message it generates at this time will span the region to other regions. Routers also receive information from other areas. Then it won't work at this time. When it is received, just tell other devices. It doesn't import at all. It doesn't have this route at all. Then this message will come back. It won't come back in this area. Instead, it will be delivered within this area. It will go haywire. I say now that you may sound a little confused. But what I want to say is, it is not absolute whether it repeats. In the same area, it is absolutely impossible to repeat. It can be repeated or not repeated in different regions.